Hey everyone. So first of all, as mentioned, I do apologize if I suddenly fall asleep in the middle of this talk. My first child was born 2.5 weeks ago, and I was bullied into doing this talk nonetheless. So we're going to be talking about why open source and container security are fundamentally broken, and maybe a little bit about what we can do about that. And click. Cool. So hi, I'm Benji. I'm the co-founder and VP of engineering at Root, which is a company that deals in automatic vulnerability remediation for containers. And if you want to know more about that, talk to me afterwards, because this is not a sales pitch, friends. Before that, I worked at Snyk for quite a few number of years. I was director there of the security R&D group, which was the group that was responsible for building and maintaining the vulnerability databases and the security databases that basically ran all of the different Snyk platforms, which is why I feel so much pain about what I'm about to talk about. So what are we going to talk about? Great question. So we're going to talk about the state of container and open source security. We're going to talk about why we end up with endless backlogs of CVEs we can't fix. And we're also going to say what steps we can do to get to a new zero-vuln paradigm. So, containers, the industry's plumbing. Now, this basically is a thing to say that everyone in this room is a plumber, unfortunately, because we deal with the messy world of containers inside an industry that doesn't really want to think about them all that much. What do I mean by the fact that the containers are basically our plumbing? So we rely on them every single day without thinking, right? And really not enough people know how they work. Think for a second about the plumbing inside your own homes. How many of you know how to actually fix the electricity and water? I'm sure a few of you do. Most of you, kind of like me, probably just panic. And that's the real problem here, because when they break, shit really gets real. And you only have to look at what happened now in Spain and Portugal when all their electricity went out to understand how true this is. Because when containers break, this fundamental building block of what it is that we're all doing, and there aren't enough people out there who are those brave soldiers who know what to do about them, things get very messy. So how did we get here? How did such a fundamental piece of our industry become something which not enough people know about? So the first is obviously this idea of coding abstraction. So we have frameworks, we have higher level languages, we go higher and higher and higher up the stack, and which means that there's more and more abstraction from the actual nuts and bolts of what's actually going on. A lot of engineers simply won't run their own containers, or even if they do it as part of some part of automated pipeline that they'll never even think about. And this also comes over to preferences. New engineers more and more like the endorphin rush of, I've delivered a new feature, isn't this fun, isn't this great? Less liking the dark holes of going into a container. And also, supposedly, this is easier, right? Like this is also what a lot of people, when we see a lot of, a lot of people selling coding academies out there because of the industry of kind of where it's at. They're not teaching people low level of how to do that. They're saying, here's some JavaScript, now go find a job as quickly as possible. So it's something which people seem to see as easier. And the news is that with AI and vibe coding and all of this other type of abstraction, it's only going to get worse. The actual understanding that people will need to do in order to actually learn how to run their machines is going to be less and less, which is great so long as everything works. It's less good when things get real. So, and let's talk about things getting real. 0-day o'clock. So this funnel over here, for those of you who have had to deal potentially with when a 0-day comes out, or even just the various vulnerabilities, is actually your little nightmare, which is how you have to go and start filtering and triaging through every single one of these different occurrences. Now, the issue with containers as well is that if you have one CV in a container, but I'm using that container in 100 different places inside my industry, that one CV suddenly is 100 different CVs running everywhere in my organization. And the exact where it's deployed, is it internet exposed, all of these different types of things changes between each and every single one of them, and I have to go and figure out each and every single little bit of this. And then I have to actually do the horrible thing of rolling out fixes without breaking production, which can be nearly impossible for us to do. And while I'm doing this, the CVEs keep coming. So we're just pushing this giant boulder up a hill, and it keeps on rolling down and hitting us in the face. And just to make things a little bit worse before we go better, those beautiful upstream fixes don't help. And what does this mean? How many times have you guys seen, oh, there's a new OpenSSH vulnerability out there and it has a fix in OpenSSH. Brilliant. I can go and I can fix that. You fools, of course you can't. No, because you're using a bullseye version of Debian, which hasn't yet released that version of OpenSSH, and it's unlikely that it will ever do so because they deferred it, because they decided that it wasn't critical, but actually NVD said it was. Oh, dearie, dearie me. So the containers are this messy middle ground between the managed and unmanaged world, right? So you have a bunch of unmanaged stuff coming in from the upstream, and then you have each of the container companies that are coming and basically trying to put some method to the madness, but every one of them has a slightly different take on what it is. Some of those takes are sensible because the code looks different. Whoopsie daisy. The code looks different in different places. And some of them are just like the preferences of those companies, and some of them are just really them saying, I don't want to fix this right now because I can't be bothered, thank you very much. And then if that wasn't even hard enough, we also have multiple releases per distro, which just make it really, really difficult to actually keep track of anything that I'm trying to do. So those beautiful fixes, they're not helping me out. So what is the current status that we find ourselves in? We have a prioritized list from my favorite CSPM, ASPM, SMSPM, whatever tool, with tens of hundreds of vulnerabilities to fix, right? Lovely, a shopping list for me. None of them actually fix it. A lot of them provide you different things of like, you can remediate, you could, this is slightly less prioritized because it's EPSS and this thing and that thing and no, but you still end up with a list of a whole bunch of things, even after they've done all that hand waving. And by the way, a lot of the hand waving is bullshit, friends, because it's really just them trying to provide a solution with something they can't solve, which is actually fix the vulnerabilities. We still have many, many more vuns that require a fix. And those require us rebasing or reworking our entire code base in order to fix it. And really, at this point, I just kind of give up. Because there isn't actually a whole lot for me to do. And if I'm at the DevOps team and I have to run after my engineers in order to fix this, then they will never do it because it's never prioritized highly enough for them and they never really want to do it. And if I'm the engineering team, I don't know how to do it because I've never really looked at a container or understood what it was. So we really end up with this kind of place where we're really kind of stuck. So now that all the violins are playing and all of the sadness is out there in the world, what can we do about this? I'm going to walk through three different things here. I'm going to talk about crawling, I'm going to talk about walking, I'm going to talk about running. So crawling. So the first thing that I can kind of say here is to start with Goldilocks images. And I've put up, and what I mean by that is not too fat and not too thin. So there's been this thing in the world which has been very much like go to the thinnest possible container ever, and that's what you should start with because then you don't have any more vulnerabilities that you bring in. Now the problem with the really thin containers without a lot of packages is they don't have a lot of packages, so they don't actually work very well. And then your developers downstream, they're like, okay, well, I need to install all of these packages into them to bulk it up. And then you end up with a whole bunch of more containers, which aren't, with a whole bunch more containers, which are fatter downstream in different places. And there's not a lot of management. So trying to go for the most bare bones, most distroless, most whatever, isn't actually a good solution overall for the organization. Even if for the DevOps team, they can say, now my image has no vulnerabilities, the organization still does. So we're going with images that have that, like you can look at kind of Debian Bookworm Slim. The link here, for instance, the link here that I put in is the images from root because I have to plug us at least one time here, which is how we kind of put the images that we sort of put in. But we're also but the thing here really is if you start right, a lot of the problems you'll never actually get downstream with because you have images which are fat enough to actually do what developers want them to do, but not so fat that they're pulling in all the development cycles and everything else in. You also want to be tracking those new releases and have automated deployment of new images as they come out. This is something which is fairly simple with CI/CD tools. I'm sure this is something that everyone here is already doing. That's why it's under the crawl. And offers scanning and triaging with a limited number of new vuns. So this should hopefully mean that you're not actually introducing a whole lot of vuns to begin with, so you're able to deal with what's coming out. This isn't going to be perfect, but for those of you who want to do something small, this is one. The next thing that we can do is walk. So there's two things here. This is building our own images. So there's two things I would basically recommend you guys do. The first is to combine multi-stage builds where basically you distinguish between what you're building, what the deployment image is, and what the actual image is that's going into production in order to be able to differentiate that and make it much simpler for you guys to manage what's going on and not pull in a whole bunch of development packages into your production. And I put a link here to a really great blog by a guy called Ivan Velchiko, who kind of talks through all of this, and I really recommend going through that. It's for a longer talk. And to use simple package upgrade commands inside your Docker file. The number of images that we run across that don't have just apt upgrade -- all on them is immense. And the number of vulnerabilities that could simply be solved by deploying that simply is there. And you can do the same for application level vulnerabilities and everything else. It's really simple steps that can make lives a lot easier for people down the road. Deploy, test, and rollback as part of your automated deployment flows. So as you're doing this and you're creating these images which are being constantly upgraded, simply have them run in development. See if there's a problem as part of your development cycle. If there is, roll back. If not, roll forward. And that way you're continually having a place where you're able to get your images out more and more quickly without any of these kind of roadblocks. And create, if possible, a centralized image repository for your organization. Don't let every developer pull in every single thing that they would ever want to, but actually have workable images for them which are using these type of techniques in order to get everything across. And then finally, run. So there are more advanced build tools. There's stuff like distroless and copacetic. So distroless, I think we've talked about, a lot of people know. Copacetic, for people who don't know, is a tool, an open source tool for managing vulnerabilities and automatically upgrading vulnerabilities inside images, which works under a whole bunch of different use cases. I do recommend checking it out and using it. They are able to solve for a lot of the issues in terms of simply needing an upgradable fix for somewhere where there is a fix for that distro. And for all those places where there's not, this is where the final thing comes in. Managing your own packages repository, and this is why this is under run. This means actually being able to add to your Docker files the ability to look for private image repositories where you host your own versions of packages where you've backported fixes into them. Now, this sounds terrible and dreadful and horrible, but hey, that's what we do. And I have to tell you, the team's here, so I don't want them to feel too bad. It's not that hard. There's ways to do this which are quite easy with agentically tracking for new backports coming out and creating automated fixes which you can work with them is something which is now feasible and possible for people to do, and it will enable you to basically have two different sets of packages that you're pulling from. The upstream versions and the distro versions which might still have vulnerabilities in them, and these backported fixes where you pull in those fixes to kind of deal with them. And that basically creates your own golden image team. If that sounds too difficult for you, hi, I'm Benji, I'm with Selling Root, and you can talk to me afterwards.